Hi, Professor Baldwin here, and today we're going to go over the composition of functions. Sometimes you're going to see a composition of functions that looks like this notation, and it's read f of g of x. And what it means is this. You're evaluating g of x, and then you're going to evaluate f with the result you got from the evaluation of g of x. Let's look at an example. Here we're given three functions, f, g, and h of x, and we're asked to find each of the following. The first is asking for h of f of 1. Remember, that means h of f of 1. So first we're going to find f of 1. And f of 1 means substituting 1 in for every x in the f function. So that is 3 times 1 plus 1. We simplify that and we get h of 3 plus 1, or h of 4. Now we're evaluating the function h for a value of 4. And h equals x cubed, so we're looking for 4 cubed, which is 64. So h of f of 1 is equal to 64. Now let's look at example 2, g of negative 2. That wants to know g of negative 2. So first, we're going to substitute in negative 2 into the function g. And that's negative 2 squared minus 2 times negative 2 minus 6. We simplify that and we get 4 plus 4 minus 6, or g of 2. So when we evaluated the first g of negative 2, we got a result of 2. Now we're evaluating g with a value of 2. And g of 2 is going to equal 2 squared minus 2 times 2 minus 6, or 4 minus 4 minus 6, which is negative 6. So g of negative 2 equals negative 6. Okay, let's look at a couple more examples. And now we're also asked to find the domain of each of these compositions. Remember that the domain are your possible x values. Now notice when we're finding f of g of x, we don't have a value for x. All we're doing is replacing the x in our f function with the function g. So our f function is x plus 1. So every place we have an x for our f function, we need to put in the function g of x. So we're going to put in 3x squared minus 2x minus 1. That replaces our x, and then plus 1. Now we need to simplify. So this is 3x squared minus 2x minus 1 plus 1. The minus 1 and the plus 1 at the end simplify or cancel each other out, and we have 3x squared minus 2x. Now to find the domain. Well, this is a quadratic, and we know what a quadratic looks like. It's a parabola, and we know that the domain of a parabola is from negative infinity to infinity. Or you can ask yourself, are there any values for x that you would get an error message? And there aren't for this. Now let's look at finding the composition g of f of x. Remember, this means we're taking the function g, and every place we have an x, we're putting in our f function. So we have 3 times x squared, and x now is the f, x plus 1, minus 2 times x, which is now x plus 1, minus 1. And let's simplify. This equals 3 times x plus 1 squared would be x squared plus 2x plus 1. Now we can distribute the negative 2 through the parentheses to get negative 2x minus 2. And lastly, we have minus 1. Let's distribute the 3. We have 3x squared plus 6x plus 3 minus 2x minus 2 minus 1. Now we want to start combining those like terms. We only have the 1x squared, and that's 3x squared. We have a plus 6x and a minus 2x. That becomes plus 4x. And we have a positive 3 minus 2 minus 1. Those simplify out. Now let's look at the domain. What is the domain for this? Well, again, are there any values that x can't be? No. So x is going to be all real numbers, or the interval negative infinity through infinity. Let's look at a little more complex of a composition. Here we have some fractions. So first we're going to find f of g of x. Remember, we're looking at our f function, and every place we have an x, we need to substitute in our g function. So we have 4 over 1 minus 5, and we have an x that gets replaced with 1 over x. This is simplified to 4 over 1 minus 5 over x. Let's get a common denominator for those fractions in the bottom. 1 can be rewritten as x over x. Then we can combine the denominator fractions to get x minus 5 over x. The numerator is the same as 4 over 1, and we can multiply that by the reciprocal of the denominator, which is x over x minus 5. And we get 4x over x minus 5. Now, to find the domain. The domain is going to be any value that is in the domain of f of x and g of x, but also it needs to be something that can't make g of x 0. So we know that 5 is not a possibility because of our composition here. If x is 5, our denominator becomes 0. So let's make a note that x cannot be 5. We also know by looking at g of x that x cannot be 0. So that means our domain is going to be from negative infinity to 0, from 0 to 5, and then from 5 to positive infinity. Let's look at the other composition, g of f of x. Remember, we're looking at the function g, and every place there's an x, we have to replace that with the value of our f function. So we have 1 over x as our g of x, and x gets replaced with 4 over 1 minus 5x. The numerator is the same as 1 over 1, and we can multiply that by the reciprocal of the denominator, which is 1 minus 5x over 4. So that simplifies to 1 minus 5x over 4. Now we want to make some notes. What do we know about x? Well, from this composition, there's nothing that'll make the denominator 0, so there's no x value that gets eliminated from the composition. But then we have to look at the innermost function, f of x. So looking at f of x, is there anything that would make that value 0? Yes, 1/5. So x cannot be 1/5. That means the domain here is going to be from negative infinity through 1/5, and then from 1/5 through positive infinity. Now that we've looked at composition of functions, let's look at how to decompose a function. So we know that there's this function h of x, and we want to decompose that as f of g of x. So h of x was f of g of x. So we need to figure out what is f of x and what is g of x. So what I like to look at are what are the steps to solve h of x. So if you were looking just at h of x, how would you evaluate it? And step 1 would be to calculate that radicand. Right? You need to calculate x minus 5 over x plus 2. And once you have that, you'll go to step 2 and you'll take the square root. Well, if you look at your function notation for a composition, g of x is what you're doing first, and f of x is what you're doing after. So step 1 is going to be your g of x, and step 2 is going to be your f of x. That means the function g of x is going to be our radicand, x minus 5 over x plus 2. And f of x is going to be the square root of x. Of course, we have to look at an application. A stone is thrown into a pond, and it creates a circular ripple that spreads over the pond in such a way that the radius is increasing at a rate of 3 feet per second. For part A, we're asked to find a function r of t for the radius in terms of time. Well, what did the problem tell us about the radius in terms of time? That the radius is 3 feet per second. So it's 3 times t. Well, part B wants us to find a function a of r, so the area of the radius, or the area for the ripple in terms of the radius r. So a of r, remember that the area of a circle is equal to pi r squared. So the area of our radius would be the same, pi r squared. Now, what is a of r of t? Well, a of r of t would tell you to take r of t and substitute it in to your a function wherever there's an r. So that would be pi times 3t squared. And if we simplify this, we have pi times 9 times t squared, or proper math grammar, 9 pi t squared. Well, what does that mean? What did we just find? We found the area, right? That's the a function of the ripple in terms of time, right? We have just rewritten area as a function of time. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos.